I've booked in another presentation by Paul Lawson. He's going to be talking about earthing and antennas. So booked him in for the 1st in February. So we've got Ross coming in on the 9th of January for our first night back. So we're getting a pretty full calendar. So I'm just trying to con people into filling into the AGM. So, but yeah, once again, great. Keep an eye on the events calendar. I'll try and keep you informed the best I can. So, without further ado, Steve's been working hard to get this set up for us, so we'll hand it over to him.
Thank you, Graham. You're right there, you've got that recording. Everybody's good? You're good? Very good. Well, good evening, ladies and gentlemen. Firstly, thank you, Graham, for conning me into it. It's a bit of practice. I'm going to do this again next week at the AREG, so if you want a double hit, feel free.
Hello. Yeah, nothing from the hall. I think there was a picture that locked my camera. I don't know what's happening at the hall.
No, I thought you were running it by the look of it, yeah.
No, I've locked my camera.
In the middle of the spread.
Can't zoom in that.
No, because I've locked my camera for some reason. And we've got no camera from the hall and no sound.
Now,
Yeah, I can see a thing that says North East Radio Club.
Yeah.
I can't hear it.
Just check they've got some sound.
yeah, that's the first thing, so I'll just talk here.
Yeah.
Can you hear me out on Zoom land?
Obviously not.
No, I can hear something from outside. We're on.
You got the sound of the morning?
Yeah, we got, I can hear Les.
Yeah, he's coming in.
Okay. Can you hear me out in Zoom land? No.
So that's,
And the little lapel, it's flashing green. That's good.
is it meant to flash green, Tony?
No, it should be good.
Should be blue. Well, it was flashing
charge
green.
it.
Yeah.
You did charge that.
I'll just need to sort it out.
So, turn it on.
Okay. Yeah, you can hear me now? Fantastic. Okay, let's try again. Take two. Well, good evening, ladies and gentlemen, all the other members out there in Zoom land. Thank you for inviting me along, Graham, conning me into it. Very happy to try and drum up a little bit of interest in digital amateur television. For those who know me, I like everything about amateur radio, and I was really captured not so long ago. Steph VK5SFA has got a really nice setup over there at Seaton and does a broadcast every single night from about 7 till 8 o'clock. And watched what she was doing, and Tom VK5ZTS and young Tom VK5TOM was all dabbling in that space. So I had a play with DVB-T probably about 10 years ago, maybe more. But the equipment was horrendously expensive, and I was working at the time and was able to just borrow stuff from work and then stuff, a little play with it and then take it back. So it was a little foray. A lot's changed. It's just got cheaper is really what it boils down to, and better. And it's up to you how deeply or not you really want to go into it. So when I started trying to put this presentation together probably about a month ago, starting to think about it, I did an experiment myself and actually for the first time used ChatGPT. And I asked it, do me a presentation for a DVB-T presentation. And I was absolutely astounded with the quality of the presentation that came back. except that it was really death by PowerPoint, and that's not what I want to do to you tonight. I've got quite a few slides here, just for some really key points. I then have all the equipment that is actually live in the hall here. I'm actually transmitting a DVB-T signal on 70 centimetres in this hall. After which, if any of you have bought a little laser STB 9000 set-top box, bring it over and I'll help you tune it up. Only have to do that once it's memorised, you take it home. If I can get all this gear back in a working fashion by Sunday morning, I've had permission to relay Bevan VK5BD's video vodcast of the WAA news. So I might pop that up, and it might give you a chance if you want to have a play around. If you've got a Yagi, just sit point in my place, see if you can see me. I don't know. Good reason to go on the air, I guess. But the point of the exercise is, it can be as complicated or as simple as you like. If you just want to be a viewer and you really don't even want to understand the technology, that's just fine. It's just really three components that you've got to put together. If you want to become a transmitter, I was going to make this presentation. I was going to call it digital amateur television. It's easy and it's hard, and I want to explain the hard because it's really important to understand that it's to do with use of the spectrum. Okay, so without further ado, I'm going to jump into the presentation. If it's okay with you, I'll just sit down because I can see my screen properly, and we'll go from there. So, is that all okay? Can Zoomland talk back to us? Can people talk back?
Sort of. Yeah.
All right, so... Okay, so what we'll do is, normally I would ask you to interrupt me. As a matter of fact, in the hall here, feel free if you want to interrupt me if you have a question. I'd rather deal with the question on the spot rather than go back to it. On Zoomland, please write down your questions if you have them at the end, and then we'll try and deal with them. Okay, so here we go. Alrighty, so I talked about homework. Look, my job today here is not to talk about a technology that's 30 years old. I mean, it was introduced into Australia in the early 2000s, for goodness sake. It's robust, it's mature, it just works. You watch it whenever you watch television terrestrially. So I asked Graham to send you guys out on your email list some homework, and there are just some words and some acronyms there that if you really want to have a better understanding, may I ask you to educate yourself? There's just a ton of information on the internet. You know, your AI and your Googles and whatnot are fantastic. But it's important, if you really want to understand how it all works, they're the things that I thought that you will need to know about how it actually all goes together. And I'm going to refer to some of these and explain them in some detail, but nothing in depth. So how does it all go together? Well, you've got an encoder usually, a modulator which will go right through a receiver, and there's basically, just get my little laser pointer here going, and a workflow. So we'll go through that. That's all set up on the table over here, and we'll set that up, but I'll just go to a block diagram which is far easier to understand. So basically, in this case, we've just got a HDMI input, so a high definition multimedia interface, standard on just about everything these days. A simple modulator, and there are modulators and modulators. In this particular case, all I can transmit is one high definition, so in other words, 1080 progressive scan, 60 Hz signal. That's all I can do with AAC sound that goes with it. If you had a different transmitter and an encoder with multiple channel inputs, the technology is so efficient that you can transmit, up to 6 video channels within the one piece of 7 megahertz spectrum. Now, I can't do that. If I wanted to go and do that, we're up in the thousands of dollars range just for the encoder. So we've got to understand here, this is very simple: one input, one picture, and one channel. From there, it comes out on 445.5 megahertz, which is the top end of the 70 centimetre band, and that is allocated in Australia for DVB-T use. And by the way, DVB-T, we now use DVB-T2, which was a progression from the old DVB-T standard, which was MPEG-2, and we've moved now to MPEG-4 H.264. You need to understand that. It just gives you far better compression. You can fit more signals in the one piece of RF bandwidth. So from there, the signal comes out, it has to go into some sort of linear amplification. I've only put one block. It depends on what power levels you want to go up to. You can have many, many blocks of amplification. But you do need to understand that this is ultra linear class A. If it's not linear, it's just not going to work, because that's the way that coded orthogonal frequency division multiplexing actually is. It's 8,000 carriers and it has to be completely linear. To give you some idea, at home, I actually can create 50 watts of RF. I don't run it that hard because I get better linearity at about 35 watts. Then it goes through a filter which has got a loss in it as well. But to get that 20 watts of DVB-T into my antenna, I need to put 600 watts into the system. So 600 watts from the mains gives me 20 watts out. So that gives you some idea of how inefficient this is, how much heat is produced, and how linear the system has to be. Anyway, from the RF amplifier, or the linear amplifier, it has to then go into a bandpass filter, and we'll talk a little more about power levels and types of filtration that is required. Simply from there into your transmit antenna, whatever that may be. It could be a Yagi-Uda array, it could be anything as long as it's horizontal. You must understand we must transmit horizontal to mitigate interference, which I will go into in some detail shortly. It's very important to understand. As a receiver, there's only 3 blocks. You have your antenna, which most probably will be a Yagi-Uda array. A DVB-T receiver, you know, I've sort of said the little STB 9000 for 40 bucks, pretty good bulb. And lastly, that comes out as HDMI into some sort of monitor or display. That actually could be a television too, and we'll have a good look at that in a moment. So the core concepts, as I said, the encoding is MPEG-4, H.264. The transport stream, which you'll read about, is just 188 bytes, but there's lots of carriers, so you add them all together and you can get up to about 23 megabits of payload to the channel. I'm running QPSK, so you'll need to understand what that is. Just a far more robust scheme, and with that I get about 6 megabits to air. But that's all I need for a single video channel, it's tons. And the actual bandwidth, the RF bandwidth, is 7 megahertz. So we really copy the Australian and European, for that matter, DVB-T2 standard. Nothing different. We're just allowed to transmit it in our own part of the 70 centimetre amplitude band. So why go digital? Well, efficiency, as I touched on, you could have more channels if you wanted to. Picture this. If, say, for some quirk of nature, we decided we want to put a ATV repeater here in Adelaide, and let's just say we could put it on Mount Lofty or on a city building, a bit utopian, but let's just say, you know, we could spend money on an encoder. You could actually have 4 logical channels. So you could have 4 receivers, let's say, on 23 centimetres, on 13 centimetres, 6 centimetres, 3 centimetres, say, and 4 people could be feeding into that one repeater and have 4 different channels going out completely independent of one another. That's how versatile the system is. It's really quite extraordinary. And that's where I touch on the flexibility. I did say it to talk about QPSK and a lot of forward error correction. I have to have a quick look on my modulator, but at least half the bandwidth is made up of forward error correction, which tends to just give you more range and better. I'm going to just use signal to noise ratio, but it's actually modulation error ratio and signal to noise ratio benefits. Look, you can stream this as well, which I'll touch on towards the end of the presentation. As I said, it's high definition video. The picture and sound quality are just fantastically digital. And it has an interesting effect. It's called fall off the cliff. And fall off the cliff is where you're receiving a signal, and if that signal were to reduce by 1 decibel on your antenna terminals, your receiver antenna terminals, and you're at the threshold, it falls off the cliff and you get a black screen. And 1 dB more and it's back. So it is just one of those technologies that, as I say, is a very sharp fall off the cliff effect. Alrighty, so this is a little bit of a look at what I've got here today, and I must apologise in some respects. This is a little Saplink DVB-T modulator. It also does ISDB-T as well, which is the Japanese standard, but for our intents and purposes, it's DVB-T2. It outputs about minus 6 dBm from its little antenna port there. Then I've got one of these little, don't ask me why they're called the golden amplifiers. You get these off eBay for about 15 bucks, and they're good from DC to about 6 gigs, and they've got about 20 dB of gain, and they're used as an amplification block if you need to bring your levels up to drive larger amplifiers per se. What I might do is I do have one here, and I will let you pass that around. You can have a look. The reason it's in my hand is this afternoon when I was doing my final testing, it died on me, and I don't know why. So hence why I've got a much bigger amplifier here than actually required. Probably the most important part about this system here is this little PC board down here. So this is made by Minikits, and it is a 450 megahertz low pass filter. And it is absolutely critical you go to air with that filter, because the output of this, albeit linear, is rich in harmonics, and that's not a good thing. It's just would be polluting of the spectrum. So that is a must. They're only about $50, very easy to make, and they work particularly well. They've got a very fast roll-off. So they're really quite good in that respect. Speaking of Minikits, so I've got many different amplifiers at home now, but I decided I would try a Minikits amplifier. This one's more designed for FM. It's a 60 watt module. I went and bought the biggest one I could, but you bias it in its most linear portion to allow for the best modulation error ratio for DVB-T. So to give you some example, it's a 60 watt module. I get about 3 watts out of it, and 3 watts is perfectly linear and works relatively well, but it produces a lot of heat because it draws a lot of current. As you would imagine, it's running linear. And you can see here the low pass filter actually built into this little enclosure. I've got a little pad on the input. The return loss on the input of this amplifier is not fantastic, so a little 3 dB pad just makes it look a little more appetising to the little modulator or the little golden amplifier. So, without the low pass filter, that's the spectrum. So that's up at about 900, and that's up at about 1500 or thereabouts, not good. You put the filter in, and it completely cleans it up. Okay, so you have to run the filter, you have to. If you go here without that, all you're inviting is ACMA knocking on your door, and we don't want that. Now, if you didn't want to go to the trouble to build a Minikits amplifier, you just want to go the approach where I'm going to spend money and get on the air, nothing wrong with that approach, by the way. You get one of these things. So I'm going to pass this around the hall. This little fellow comes from China. It's a completely linear amplifier designed for DVB-T, ISDB, you name it, any sort of amplification from an RF point of view. And I landed that for about $105, and don't be fooled if you look on the back, it's got 4 watts written on it. Yeah, 4 watts, PEP. Once I read the specs on the transistor that I blew up. 1 watt all day, 4 watts PEP, so don't expect 4 watts out of it because it will destroy itself. So hence, that's it, but you can have one of those within a week from AliExpress, no problem, and it will work just as well as the Minikits one, but I brought the Minikits one here today just to show you that you can build stuff. It's just for the people in Zoomland, that's basically what it is. It's made in China, and the build quality, you'd have to say, is actually very nice. It's just quite a nice little milled aluminium enclosure, as you can see there. So, really quite nice. Alrighty, so here comes the serious part of this conversation, ladies and gentlemen. This is really important. Okay, so as we touched upon, digital and television, our allocation in the 70 centimetre band is in the channel from 442 to 449. 7 meg continuous piece of spectrum. That's what this will occupy the moment you turn one of these modulators on. You have to be aware that commercial services start at 450.025 megahertz. There's 1 and 025 megahertz guard band. It's virtually nothing. In some respects, in my opinion, the band should have been 441 to 448 and just give us a little bit more headroom up the top, but it never was. The horses bolted, that's what we have. I'm going to quote Roger up in Whyalla VK5WRF here because he was giving me a lot of guidance on my journey when I was getting started. He believes, and I tend to agree, up to 1 watt PY into a high gain Yagi Uda array is acceptable without a bandpass filter. You've got to use the low pass filter that we talked about, that's a must, you've got to get rid of the harmonics, and the antenna will help as well, but that's acceptable because the chances of you pointing at something for long periods of time, you know, on average, it's probably not going to interfere that particularly badly. And believe it or not, a reasonable antenna, you know, 10 to 15 elements, can get you all across Adelaide without any problems with a watt of input. As I did touch on, you have to use the low pass filter. If you want to go above a watt, so let's say up into the 5 and 10 watt range into your antenna, you have to have a filter. You have to. Because if you don't have a filter, you'll get noise in that other segment up at above 450 and you will start interfering with other services. As I mentioned before, you've got to be horizontal because all these other services are vertical, so you're getting 20 odd dB gratis of cross polarisation. That's really, really important. But let's just bring it back to reality here. So I live up on top of the hill there. I'm putting about 25 watts into an omnidirectional antenna system that covers all of Adelaide, and the closest users, SA Water and Adelaide Airport. And you don't reckon I illuminate them very well? Well, I do, but because it's spectrally pure, there's no problem. You've just got to keep it in mind that you have to really, really focus on your filtration if you're going to higher powers. Here's the last thing to really focus your attention. That is users within 450 to 455 within 100 kilometres of an Adelaide. So don't put your head in the sand, they're everywhere. And all I can see happening is if people don't do this and they start interfering with these other services, say Adelaide Airport, you don't reckon the ACMA will be knocking on your door the next day. They will be confiscating your equipment. If too many people do this, ACMA will say, this is too hard, we are banning digital amateur television in the 70 centimetre band, switch it off. And there ended the really harsh lesson, okay? I think you understand where I'm coming from. We have to be very, very careful to preserve that such valuable spectrum and the privilege that we have to be able to transmit these signals. So how do you do it? Well, filters, as I've learned the hard way, I tried to make one. Sorry, I'm popping a bit. Okay. Yep. I tried to make one, and whilst I got the bandpass to be really quite nice, the insertion loss was about 6 dB. I couldn't get it any better than that, and I had to go. It was a 6-digit interdigital. This is a comb line, and comb line in actual fact means that all the digits are at an earthing end at one end and at high impedance at the other. So this is a commercial one that I was given. And it was on channel 28 back in the day when we used UHF television in the cities. This was probably used for a translator somewhere. So after, I'd hate to tell you how many hours of playing around with it, I worked out that if I could lengthen the digits, which is what I did here, you can see if I just go back one, you can see there that's set up at 425, you can see that length, sorry 525, and now that's set up for 450, and it worked really, really well. And I'll show you the S11 and S21 plots here for those who understand that, but in actual fact the ripple is excellent within about a dB. The return loss is a little bit lumpy, but I don't know what you do about that. It's a filter. It's probably coincides with the best insertion loss. You're getting the best return loss. That's usually the way with filters anyway. But that was a really good effort. You know, it ranges from 1.2 dB at one end to about 1.78 dB at the other end. That's the best I can get it. And these things are really hard to tune. They take hours. But once you get them right, They work quite well. And as you can see, they roll off really, really quite quickly. The other thing that I experimented with to try and get the skirts on the side of the passband a little steeper was good old-fashioned cavity notch filters. And you can see by that little photo there, a pair of cavities, one tuned at 441 and the other one tuned at about 450-ish. And you can move that around to suit. And that's what it kind of looked like on the spectrum analyzer, again, with very little insertion loss. Now, if anybody decides to become a transmitter and decides they want to go higher than 1 watt, and you can prove to me you're serious and you're going to do it, I have a supply of these cavities that I will give you. Okay, so, but I'm not giving them to you if you're just going to put them on the shelf. It's not going to happen. So the only homework you've got to do is you've got to make the loop yourself, because I've got all these cavities without loops in them. So I pitched all the loops. So anyway, I fixed them. Alrighty. So that's what a DVB-T signal looks like. In between the 7 megahertz channel, inside here there's 8,000 carriers going on. And that's how it works, and that's your homework. You need to go and learn about how that actually works. But you can see here the sideband noise, it's only 30 odd dB down from the peak power here. So just for fun, just using just those 2 cavities, that's the result that I got. It was really good. Put another extra, 10, 15 dB into it, and that could be very, very handy if you're interfering with a particular service. You could just put your notch on your transmitter on that service and it will go away. So there's all sorts of tricks. It's not doom and gloom here. I'm just trying to show you the things that you can actually do. So that's a picture of my 50 watter. I'll just sort of point out little things as we go. In this case, I was just using the little modulator here. I was using the little mini-kits amplifier as a driver. This thing's got 4 stages of amplification in it and draws enormous amounts of energy. It all goes into this really, really big, I'll try and just magnify that if I can. I'll just turn the pointer off for a moment. How do I do that? There we go, my mouse back. No. No, not going to let me do it. What have I done? Lost it altogether. Never mind. So, this big black thing here is a commercial DVB-T filter. So, it's got 6 digits on it. There are 4 bandpass in the middle, and the 2 at either end are band reject, they're notches, so they get incredibly steep skirts on them. And my spectrum is as clean as a whistle. I've been on for hours and hours and hours and hours and hours, and if there was interference, someone would find me pretty quickly. It wouldn't take long. Never heard a word, so that's really good. Now, the only way to measure power is actually using a bolometer. Now, for those of you who don't know what a bolometer is, it just measures heat. So basically it's got a sensor on it. I've got it here today which we'll show you, and you have to go this road because the channel width is so wide. Spectrum analyzers do not believe what you see on the spectrum analyzer. It may say 0 dBm, it is not. Its bandwidth is just too narrow to look at that whole 7 megahertz channel. You have to convert that whole channel into heat and then display that as a calibrated output in watts, and that's how you do it. The other piece of test equipment which I've got here today is a little test set made by the same company who make the modulator. Sat King make them. There's quite a few different brands, you don't have to be tied to anything. It will tell you all sorts of interesting information with regards to the packet identifiers. It'll tell you about the modulation error ratio, it'll tell you about your bit error rate. And all these things you've got to go and learn about, because they will tell you the health of your system and how linear your amplification system is and the like. So it's a really nice, and it's got a little screen on it, and you can use it as a little monitor as well. So, and it was about, I think, about $160 landed, so not big money. Ultimately at home, I've got a little mini rack. So here I've just got all my HF stuff, and then the digital amateur television down the bottom there, and it just sits there and I turn it on when I want to use it and the like. I just thought you might be interested in an antenna system. As I said, I live up on the side of the hill there. Wonderful view of Adelaide. Got to be horizontal. You can't just stick up a white stick on 70 centimetres. Don't do that. It's vertical. You will lose that 20 dB isolation and really potentially interfere with other services. It must be horizontal. So horizontal and cardioid and omni starts to get a little bit harder. So I did a trick that I used back in the early 2000s. Maitland will remember this. I was on 23 centimetres with exactly the same antenna system, and it would light up from Darlington to Redwood Park without any problems, and everywhere in between. And how that works is just a set of 3-element Yagis. They happen to be DL1WUs. I really like his design. They're quite smooth, symmetrical patterns. They've got folded dipoles, which does bring you back, if you get the ratio right, to 50 ohms. Because when you start to want to do power division, you've really got to be in whatever impedance you choose, but I chose 50 because it just conveniently connects to a coax that's feeding it. I made the power divider myself. These are not hard to make. You've just got to get the right ratio of aluminium square tubing and copper tubing inside, and it's a ratio, and that will transform 50 ohms down to about 17.9 ohms from memory. And if you put 3 50 ohm antennas in parallel together, what do you get? 17.9 ohms, so your power gets divided 3 ways equally, and they work really, really well. Nothing new here. That's just a little picture on my little mic stand, just to show you the setup and my testing. But most importantly, the return loss was spectacular at 31 dB. I was really happy with that result and good bandwidth. And my transmitter is very happy, and I get 0 reflector loss pretty much. It's good. And that's just a picture of it in situ. So as you can see, that Yagi there is pointing due north, that one is pointing due west, and that one is pointing due south, and they've got about a 60-degree beam width, so they just all overlap really quite nicely. I'm sure there are phasing issues out in the field, but no one seems to complain, so that's really good. Okay. That's basically what I've done. The next bit I want to show you, you may have a digital amateur television receiver at home and not know it. There you go. Some televisions will natively tune 445.5 megahertz. Let me show you how. So that is a photograph of my lovely LG 55-inch smart television. It's running WebOS, so if you've got an LG or anything running WebOS, I can't talk for anything else, but when you wake up tomorrow morning and you've got your own little telly out in the shack and whatever, and it's running some smart system, or maybe native, I'll get you to check this. So all you do, in the first instance, in my case, you've got a general setting here, and you get this tab that comes up. In my case, you've got to choose programs here, which you do. Then you go and find program tuning. So this is just a convoluted way that LG get you to manual tuning, by the way. You get a little spinning wheel of death that lasts a little while. Then you get to a point where it says manual tuning, and you go, yeah, that's exactly what I want, manual tuning. Do you want digital television or analog television? I'd like digital television, please. And here comes the magic bit. So this television will tune from 47 megahertz to 820 megahertz every frequency. So, type in 445.5. I like that idea. Submit. Do an update or a scan, and it says tuning. Voila. You suddenly have a digital amateur radio television in your lounge room that you never even knew about. Now, kind of works for me because I've got a few viewers who've got their TV in their lounge room, and their antenna, which used to have UHF on it, pointing at Mount Lofty, which is well out of band at 500 megs, doesn't matter, it's sort of pointing past my place, and they can see me no problems in their lounge room without doing a thing. So these are the sorts of things that are possible. For those of you, this is what I was banging on about. This is a little laser STB 9000. You can pick them up at Woolies, you can pick them up Big W, you can pick them up at Harvey Norman, JB Hi-Fi, you name it.
$32 at Big W.
Big W.
32.
Yep. Yep.
That's what I mean.
Yep. You open up the box, that's what you get. your little set-top box, you get a remote control, you get a power supply and a couple of batteries, all for $40, pretty good value, I thought. To tune it up, you plug it in, you plug it into a monitor, you select your region, Australia. You want DVB-T installation. You want to do a channel scan. You want to scan by frequency, so this is really important. This one up here, it'll be either by channel or by frequency. You want to change that to frequency, it's very, very important. You type in the magical numbers of 445.5. You hit scan and voila, you've got a digital amateur television receiver, just like that, with sound. If you've got speakers in your monitor. Okay. So there endeth the death by PowerPoint. I was thinking from there we just go to a practical demonstration. Then I want to show you a thing called OBS, which is the Open Broadcasting System. It's all terrific to have this, but you've got to remember you can have technically the best television station, radio station on the planet, but if you don't have the content, nobody's going to watch it. Content is king, remember that. So OBS ties this all together and it's free. And it works really, really well. And I'm going to give you a demonstration of it when we're finished, and then we'll take some questions. Alrighty, so if that is the case, and without further ado, what I will do now is just find my mouse. And we'll get rid of that and that. We will bring up said OBS, which I can only see at the moment, so we'll just get this transmitting to the projector. Hopefully, look at that. Slightly overscanned on that, but that doesn't matter. And then what I'm going to do is I'm just going to bring up the little camera that I have here. So I'm now going to have to move to the front here and just point stuff out to you. And I didn't know what I wanted to do. Transition. Forgive me. That's better. So you can already see I just went from a test pattern to a camera. Click of a mouse. Yep. Free. Really cool. Alrighty, so I'll just point to things. So you probably see me in the hall here. These are for the people probably out in Zoom. So we've got a power supply here, and that's powering my linear amplifier system, little Waverley Amateur Radio Society power pole breakout box. These are really good, by the way. They're about $50. You build them yourself. They're excellent. So over here is the DVB-T modulator. Now, if I can just put the mic down for a moment, I'm just going to get the camera to focus in on the display here, so you can actually see the settings of how you set things to, okay? So just give me a moment. Okay, I don't know how well we're going to be able to see this, we'll just try. So, basically you have a menu system here. I'll just have to read them out. The first one is called the quick, wrong glasses, quick install. Then you've got the DVB-T settings, the TS transport stream settings, and then your system setup. So, if I were to go into the DVB-T settings, you'll see here, that's where you set your frequency. That's where you set your channel width at 7 megahertz. In this case, I'm using 6 dB of attenuation, and the output is HDMI. And that's all you have to set up, really quite straightforward. And I've set the logical channel number to 100, so that's what will show up on your television. Now, it's a very important point to make here. Now, I'll make it in a moment as we go through these menus. So, the next menu are the DVB-T settings. So this is your homework. This is what you've got to go and read about. So I'm running 8K carriers, so 8,000 carriers. We're running QPSK. I'm running 3/4 forward error correction, which is a lot of forward error correction, but that just gives me more range and allows you to work in a poorer signal to noise ratio, or MER, and the guard interval is at about 1/16. And guard interval you'll read about, but we have a lot of aircraft movements, and it handles Doppler shift better. But again, you're going to learn all about that when you do your homework if you're interested. Now this is the really important one. This is all the packet identifiers. So you've got a video one and you've got an audio one and a channel one and so on and so forth. We had a breakthrough in Adelaide, and it was a really good one. It was between the 4 users that there are at the moment, the 4 transmitters. So everyone was running their own PIDs. And that's problematic because if you as a viewer on 445.5, let's say you tuned your set-top box to me, and let's just say Steph came up, 5FQ, and she was running a different PID, you'd get maximum signal strength, maximum quality, no picture. So you'd have to do a channel scan on her to pick up all her packet identifiers, memorise that on another channel, and then you have to switch channels. But you're not switching RF. It was really silly. So we all got together and said, you know what, this is our one chance to get it right, and we all agreed that we will all have the same packet identifiers, which means it doesn't matter who you are pointed at, whoever is transmitting, you only need one channel in your set-top box. And that just made a lot of really good sense, so we've done that. And in that case, this one is in decimal, but you'll see on the little test set, they're actually in hexadecimal, so they're just same numbers, different format, that's all. Okay, if we go back out again, in the system setup, you can, as I said, you can have DVB-T, ISDB, all these different ones, your tone when you push the button, and a factory reset, and that's pretty much it. It's all really straightforward, you know. You just set those things in, it'll give you about -6 dBm out of RF at whatever channel frequency you put into it. It's that hard? No, it's not. It's really, really straightforward. Okay, I'm just going to have to pop the microphone down again for a moment, just move the camera so you can then see. Matter of fact, I might even just try using my handheld camera. It might be a little bit easier, I think. So we'll go back over to our OBS here. We'll select the next camera and transition it. Forgive my hand shaking, but I couldn't think of any other way to do this, especially for everybody on Zoom. So forgive the movement for the moment. Get this in my hand properly. Okay, so here is a picture of my linear amplifiers and my filter. I'll just give you a top view here so you can see the filter really kind of looks like a filter. And that is the cone line filter that you saw some photos of, and the box underneath it is the mini kits. This great big one here is normally used for much higher level, but as I said to you, my little golden box died. So this great big blob is doing the same box as the little golden box, I'm afraid. Okay, so let's just switch it on, and we'll put some cameras on this in a moment. So there's a real-time display of that's getting cut off over there. Gee whiz. The wrong resolution on the projector, there we go. That's just giving you filtered spectrum, and quite importantly here, that's the bolometer. So we're creating about 2.6 watts, and that is channel power. All right. So the other thing that I can do, I'm just going to pop the little camera down for a moment. I can just bring up the menu on. Gee whiz, there's no way you can get your project. I don't know how you're seeing that out in Zoom. That's really cropping the picture, and I don't know why. And that's direct, yeah, that's a direct feed there. So if we can't fix it, I'll put the camera on it if we can't fix it. Yeah, let's just do that. I think that's probably easier. No, I can't even do that. unfortunately. You'll have to take my word for it. This just tells you very important information, as I talked about, the bit error rate and also the modulation error ratio, which is very important, and it tells you all the packet identifiers. So it's just a little off-air test set, and it measures everything for you conveniently in dBm. So really good if you've got an antenna fault at home, you want to look at your terrestrial television or what have you. It's, the other reason that I bought it, it also does DVB-S. So if you've got a satellite system and you want to line up a satellite dish, it'll power up your LNB for you so you can point your dish properly and see the video carriers, and it'll do single channel per carrier, and it'll do DVB-T multi-channel per carrier or per spectrum. So that's the story on that lot. All right, let me rig up the other camera here. I'll just point it at the spectrum analyzer. I just want to show you a couple of little things quickly, just to do with what filters do and what they don't do in real time. Then we'll go through OBS and then I'm done. So just bear with me a moment. Okay. See how well this works. Forgive me, I'll just put the microphone down for a moment.
I just have to turn that on-screen display off there. Steve?
I'm really sorry, we're just having an issue here. I mean, you can see on this monitor how it's displayed, and on the projectors are different things. So, okie dokie. So, as I say, there is the filtered spectrum. What I would like to do very quickly is just take the filter out of circuit so you can actually look at the spectrum and just see how much effect the filter is actually having on it. So what we'll do is we'll just turn off the amplifier for a moment. It should all just disappear. I will just put a simple barrel here. I've just got to put the mic down for a moment. Okay, thanks for your patience. Now, we'll just bring the amplifier so you can see all the noise just rose up at the side there. Just use my knitting needle here so you can actually see. It's all this area here that you're going to start to get to other services, because you've got to remember this is 450 megs up here, and this is the repeater band and amateur radio 70 centimetre band down there. So you've got it's affecting us as well. It's a symmetrical thing. So what I'm going to do now is I'm going to put the filter back in, and then I'll just show you the effect of this. I just brought a single cavity, so we'll just look at one side of it. And I've just brought the 450 meg one because that's probably the more important one. It's okay if you upset amateurs, it's not good if you upset other commercial users. So I'll just put the filter back in. Okay, so that is now amplifier back on. Something funny here. I have no idea why that happened. Ah, there we go, loose connection. Okay, so what I'm going to do just for fun is, I know this is not particularly kosher, but I've got a little T-piece that's sitting here that's unterminated, which is probably not good at 70 centimetres, but what it will allow me to do is just put the cavity on as a notch, and you can see what happens. So hopefully, let me see here.
It has reduced it a bit.
Yes, no, it did. It actually brought it down a little bit further. So it just shows you there's a little trick in your kit bag that if we've got interference problems, they're fixable. And as I said, just bear in mind I've got quite a few of these cavities that you need to make your own loop, but I've got all the dimensions, so that's not a problem. So that is pretty much it there. I'll show you the last little bit of the setup, and then we'll quickly go through OBS. So just give me a moment. Okay, I'm back on the little handheld camera here. So just to show you the setup here, I've got oops, if I can just point this correctly, so get it right for the projector. So that there is just a little 20 dB inline attenuator, and the output of that goes into a little mini circuits splitter, and that then allows me to drive both the spectrum analyzer and the bolometer at the same time. And that's just got 4 dB insertion loss, which I've accounted for in the bolometer, which you can do. And off it sort of goes. So that's pretty much the test setup. So I might just turn this camera around on the audience here. And come around and we'll have a little talk about how this OBS in actual fact works. So just give me one moment where I'm going to just change my screen so you can actually see it. Okay. So I'll just bring up OBS again. Hopefully this will do what I want it to do. Okay. So OBS, I'm not an expert with it. I just use it as a practical. You can do so much with this. You can do video presentations. You can do all sorts of marvellous things. But what it gives you is a whole palette of sources. Where if you can just see my mouse here, and you can also see that it has an audio mixer as well. So you've got all the tools that you need for video and audio manipulation and production to some extent. So this little source thing's hierarchical, so if I was to highlight my test pattern, bring it up, you can see it in my preview screen over here, but you can't see it on the right hand side. You're still seeing my little camera here looking at you. But I'm just going to hit the transition button, and suddenly it puts that to air. Okay? So really cool. And you can do some little interesting things here. If I go back to my little camera that's looking at you, I've just got a little, my call sign, oops, that will just do a transition. And there we have, I've got my call sign there, so that when I'm on the air, you actually know who's actually transmitting. You can have any text that you want, you can have scrolling text, all sorts of really interesting things. You can embed video into this, so let's do that. We'll turn off the camera, and I've got a little video here. Let's put this up here. A little bit of eye candy, so I'll just do a transition. Here we go. And that's got full sound, by the way. If I can just get that for you. Really quite cool. And you've got a little player here. You can pause it, you can stop it, you can rewind it, you can do anything like that. If you've got still pictures, no problem. We'll go to some still pictures. These were taken at the 2022 John Moyle Memorial Field Day at my station. So I'll just do a transition on that. That was a top-loaded 12-metre vertical, which served me well. My VHF, UHF antenna systems. Close-up of them. And this just goes around and around and around in a little, that's my station inside my car. It's all really quite good fun, so there you go. So these are the sorts of things that you can do. Probably one of the most interesting things though, I'll just put it back to a test pattern, I think. One of the most interesting things that you can do, and I can't demonstrate it here because I don't have the internet, but that is, OBS has got a built-in WebSocket into it. Now what that means is that if any of you people decide, hey, you know what, I want to broadcast something on ATV to Adelaide and I'm going to ring up VK5SFA and see if he wouldn't mind relaying me, because he's got such a good coverage of Adelaide, all you need to do is download a copy of OBS onto your PC, free. Open up a couple of ports on your router, not very difficult to do. Plug in your web camera, have your content ready or whatever it might be, and point it at my IP address with the correct port on it, and it will instantly come into my OBS and then get retransmitted out on my ATV signal, and anybody can watch you. And we all happily talk back on, as you can see here, 147.4, which is, by the way, the Australia-wide allocated ATV liaison channel. So if I'm ever on, that's where I'll be listening if you want to talk to me. So that's a really quick overview. It does a whole lot more. Probably people know about it more than me. But look, it's free. It ties all your hardware into it and allows you to create some content for people to have a look at. So I guess at that point I'm going to say the presentation is concluded. I'm very happy to take any questions if anybody has any.
Steve, I've got one if you don't mind.
Yes, we'll give you the microphone so that the people out in... No, the people out in Zoom can't
I'm
hear.
having computer lessons now. They're all art blokes, but they are. I'm learning how to use a computer now, and could you tell me, in slow speed, so I can write it down, because I'm having a teacher tomorrow come, right here, and what to look up to see how it all works. If you said it too fast, I couldn't write it down.
Oh, okay. Sorry.
I can write it all down.
Yeah, no problem. So you're not a member of this club? You are a member? You've got an email that's all on it. Check your email. Oh, you haven't got your email. Right, okay. Well, I'm not sure how we can do it. Okay.
So if you go on this address...
Well, you Google it, that's what I'm trying to say. So Google's a search engine, you just put all those terms in, it's going to spit back a lot of information, and you're going to have to do a lot of reading and ask a lot of questions. No, you're right, Maitland, no problem. Anybody else got a question? Great.
The set-top box, I think the set-top box before, I think you said you had it set to 6 megahertz wide.
7.
7.
Okay. 7. It's Australian. Yep, fine.
Yep. So 7 megahertz is the bandwidth, it's the Australian standard.
Kilometres.
Yes.
There wouldn't be many of them left.
Oh, you can still buy them, they're just... These bits are cheap, it's the heads that are really expensive and people blow them up pretty easily, so... Yeah. But if anybody... here's my output of all of this. If you decide this inspired you and you want to go down this road, I'm very happy to help you. Steph would be very happy to help you. You're not alone. We've got the test gear. You build it all, bring it over, we'll run it up, we'll make sure it's all okay, give you the tick of approval, take it home, plug it in, and off you go. Tony.
Just a quick one. You're all on the same frequency, and if you want to broadcast at the same time, it doesn't matter. Or how does it? Yeah, that's what I thought.
That's a good question.
Yeah, and the other one was your type of content. When we tune into you, what can we expect?
Well, that's a good question. It's two good questions. So the first of all is COFDM, which you're going to do all your homework and read all about, is not very compatible with on-channel or co-channel interference. All you will get is a blank screen. It doesn't work. So only one transmitter at a time. But that's yet to be proven, because I don't know if someone's got a high-gain Yagi pointing that way, say to the east, and I've got a high-gain Yagi and I'm some kilometres away pointing to the west, or someone's pointing at me, can we get away with protection ratios? I'm sure we can, but I don't know what that number is. And that's all part of the experimentation. What I can tell you, when I was working in this space before I retired in television, up in far north Queensland, there was co-channel in Cairns and Mackay. So Townsville had a completely different set of frequencies, but they reused their frequencies over again. And sometimes you get tropospheric ducting down the coast, and it would last for days, and our viewers would be ringing us up and going, well, you're off the air. Well, no, we're not off the air. And suddenly we worked it out, that in actual fact, it was the code channel interference just killing it. For some people who had their antennas looking back the wrong way. People looking the other way, the front to back of the ratio of the antenna helped. So it's very susceptible to interference. What sort of contact would you expect from me? Look, I get up there with a few different things. Things that I'm doing, things that I'm interested in. I pop up from time to time. I mean, Arthur's a viewer, Neil 5KA, Don 5KT, Maitland 5LI, Tom 5ZTS, Steph 5FQ, Tom 5TOM. From memory, they're about the only ones, but hopefully by Sunday, after we tune up your set-top boxes, we'll have some more viewers, which will be just fantastic. But remember, if you've got some content that potentially you'd like to put up, all you have to do is get a copy of OBS, get yourself a little webcam, which you've probably got. If you've got some video content, learn how to drive OBS. We'll open up the sockets. You can send it up to me over the internet, and I can then broadcast it out. Easy. Who would have thought you could do that? And it's simple. It's simple. It really works.
Was it 2004 grand final?
Yeah. Oh, no. So here's where you've got to be really careful now. So, and that's an interesting statement. Remember, we have to sit within our license conditions here. Okay, so I'm not going to go and tell tales, but sometimes people put content on that they shouldn't. Okay, this is purely for technical enhancement and self-learning. That is what our license determination says. Okay, so I think, you know, I gave an example for argument's sake. I've got a friend of mine who is a shooting enthusiast, and he was annealing his cartridge cases to reload them, but using a gas torch. And the trouble with the gas torch, it was poisoning the brass with the oxide that was created with the heat, you know, and I went, I reckon we could do that with induction. So I built him up this induction coil annealer thing that we adapted to his system, and I don't know if you ever, when you were younger, played that game called Mousetrap, you know, where you had to build all the bits together and you crank the handle and a little boot, click the ball, and a sort of race, but you might, anyway. So we built another modern version of that, and it was an induction annealer, and it was really something cool to look at. And so I did broadcast that. Now, is that absolutely technical? Debatable, but it's got electronics in it, and it's got timers in it, and Hall effect switches in it, and stuff, and I think it was okay. You know? But you can't go and grab Netflix or whatever you just can't do that. We're not allowed to do that.
Illegal.
So.
No music,
No music, no, because that's copyright, right?
Yeah,
See, we live in a litigious society, you know.
Yeah.
But now, having said that, this leads us down a rabbit hole here. So, young Tom, who I find is very creative, you know, he puts some really good content up for you guys with his technical tips and so on and so forth. You know, he had a long discussion with me about this, and I said, look, I don't think it's an issue if you find something technical. So there's a few people on YouTube who do some great radio frequency stuff, but it's their intellectual property, it's their IP, right? I said, why don't you just write to them and ask them, tell them what you're going to do, and see what they say. Well, every single one wrote back and went, not a problem as long as you credit me, and as long as you don't alter the content. Fine. I mean, people are normally reasonable. I don't think Channel 7 would be reasonable if you're relaying the news. I think they'd be all over you like a rash, and you could potentially lose your licence.
or more.
Or more, so they're the things to consider.
Are you able to tune me up tonight?
Absolutely. So when we're finished here, and I can have a little drink of water, those who brought their set-top boxes will have a signal, we'll tune them up for you nicely, and you can go home with a completely functioning box. So as long as you've got a signal from myself or from Steph or from Tom, it will work. And it's surprisingly low level. Sorry, Adam.
You were going to mention your little, you just need to mention your little secret about your transmission tonight.
Oh yes, thank you for reminding me. Yes, that's a very good point. So tell me, look, I'm just curious, I'm just doing a quick survey, and I'm afraid people on Zoom land probably can't come back, but tell me, who has actually watched the digital amateur television transmission here? 1, 2, 3, 4, 5. Actually, all put your hands up, please, everybody. You know why? Because this whole presentation that you saw has just been transmitted over amateur television. There is no wires concerned. Now there you go. So that's how good it is.
Yes.
Thank you, Art. I nearly forgot. So I just thought I'd kept that little secret there. Is the HDMI signal going over to the other side there is coming out of that receiver. No wires. There's actually wireless to that receiver. So that just shows you how good the quality of it is. Thanks, Art.
And this is going to YouTube.
Beg your pardon?
This will go on YouTube.
Okay, no, that's fine.
Yeah.
No problem at all. But that's good. No, YouTube's your friend. That's interesting content. Sorry, go ahead.
The width of the antennas?
Mine? Yes, so the three Yagis are 60 degrees each. So they just overlap it in a sort of 3 clover leaf. Yeah. Now, there's certainly there's phasing problems, I know it. But, of course, COFDM, you can lose half your data. Forward error correction will take it up. You wouldn't even know.
Where do we aim at disposal Yardie's actually?
Okay, do you know where Ross Trevor College is?
Yes.
That's your landmark. I live right above that.
I've got my caravan TV thing on a pole.
Okay, give it a go.
Is that good to go?
Don't know.
So I can see already.
I'm only about a couple of kilometres from Steve, but I can see him on a vertical broadband UHF broadband antenna that's vertical with the set-top box. So you'd be surprised what might work. Just stick something up and have a look.
No, indeed.
If nobody's transmitting, if nobody's transmitting on the band, it's just nothing? Or?
Nothing. It's just a black screen. So you don't get any noise, white noise on your screen or hiss coming out of your loudspeakers. That's a good question. So if nobody's transmitting, what do you see? Nothing. You see a black screen. As a matter of fact, what I could do is just show you.
I'll make a minor correction to that. If you're using one of those set-top boxes and you leave it on, it will have the last frame that it saw on air. And that remains there, which can do your head in a bit sometimes, but in the background it says no signal.
So let's do that. If I were to...
There it is.
There we go. That's what it says, sorry. So you can see that message that just came up there. It just says no signal. That's what you will see. And then if someone started transmitting, just like that.
But the set-top box do.
Yes. Yes, they do.
The old ones do show the last frame.
Yes, and the new ones too, the little STB 9000s that I've been talking about, they will hold the last frame. So if the last thing that I had was a test pattern and I switched off, that test pattern would still be there until you recycle the power on your set-top box. That's a very good point too.
What night's you on there?
So I'm not a very constant transmitter. Steph 5FQ at Seaton, she's on every single night from 7 till 8, always. She puts output. She's got a very similar antenna system to me. She's got 4 Yagis looking every which way and actually does a pretty good job around Adelaide. And she retransmits all the content from up at the Iron Triangle. The guys up there at Whyalla and Port Pirie and Port Augusta are really into their ATV, and they do all sorts of interesting content. It really is worth a look. It's on every night. So that's a good way to test if you can see a DVB-T transmission. I'm going to try and come up on Sunday mornings the best I can. I can't commit to it all the time, but as I said, I've got permission to do the broadcast, and I might, if I can get all this back to a running order at home, I might try and transmit the broadcast on Sunday morning, give you something to look at, and do a call back afterwards.
Actually, I've got a question for you. My question is, I have an LG TV in my bedroom. If I tune my amateur TV signal, would I still be able to receive the commercial TV signals?
Yeah, great question. Oh, excellent. Good on you, Darren. Good. Now, that's a good question. Absolutely is the answer. Every single valid channel, DVB-T channel, and all the logical channel numbers in it, the LCNs, are memorised in the box. So you'll see, you'll get, let me try and think about this, you'll get I think Channel 10, then Channel 2, then SBS on the 30s, Channel 7 on the 7s, 9, and then us on Channel 100. It'll be the odd one out, it'll be right at the bottom. And that's how it orders the channels for you, if you do a complete channel scan afterwards.
Okay.
Yeah. All right, any other questions? Well, that was pretty comprehensive. That gave me a really good run. Thank you for... Oh, sorry, Graham.
One last question, what is ODS now?
OBS?
Yeah, OBS, software authentic.
Yep, so the open broadcasting system.
Yeah.
Software, I think, actually stands for Open Broadcasting Software.
Open broadcasting software, sorry, that's it. OBS, free.
It's Linux.
Thank you.
All right. All right, well, I'll hand you back to your President. Thank you very much for coming out on a Friday night and listening to me.
Yeah, thanks very much, Steve. Brilliant, absolutely brilliant. Made for a great night. So, what are you doing in February? I've got a vacancy.
I'll have to pick up something new in the hobby.
Yeah. So, if you haven't read up on it, our Saturday afternoon venture later in the month, at about around 3:15, I think we've worked out, we'll be setting up a set-top box and the projector, and Steve's going to broadcast a program to us that we can watch. So that's our practical exercise for the month. So thanks again. So anybody that's bought this set-top boxes that want to go tune in with Steve will steer you in the right direction. Thanks for coming.